Hello, and this is the IT 4983 Capstone project for the summer semester of 2021 at Kennesaw State University. This is the final presentation. My name is Tianna Porter, and I am the team lead. Our team members are Yosley Suarez, Cameron Hankins, Michael Jones, and Claire West. Our project was Project 3, Representation Learning for Motion Sequence Retrieval. Our project sponsors were Dr. Lynn Lee and Dr. Yin Ji. This is a part of a major project on developing a smart workout assistant. In short, the program analyzes a user's action sequence during exercises through camera, then queries a video of the same exercise from a professional trainer to show to the user as a reference. This project aims to develop a technology that converts the video of people and actions to a representation that can be used in retrieving the most similar videos with both accuracy and efficiency. You are expected to assist the faculty sponsor on testing different representation learning technologies and provide a report that compares the tested technologies' accuracies and efficiencies. In our milestone one assignment was geared towards developing a smart workout assistant. The program should be able to analyze a person's actions during exercise with video and try to convert that video so that it can be compared for accuracy. For example, if there is a video of a person doing squats, the pose estimator should track that person's movement and jointly detect the key points of that individual.
My name is Michael Jones, and I'll be presenting Milestone 1. What is Open Pose and Pose Estimation? Open Pose is a software that detects the human body on single images in real time for a multi person system. With Open Pose, you can have either 2D or 3D pose estimations. With 2D pose estimations, you would have to identify the key points of the body and join those key points to form a skeleton structure. The 3D pose estimation can be formed from that skeleton structure. Pose estimation is the process by which the configuration of the body from a single image is estimated would be called human pose estimation. Pose estimation predicts a person's joint position in video or in an image. What is open pose and pose estimation? Pose estimation is for, relied on heavily for assimilating any motion in technology. For example, the game developers use pose estimation for or to create like motions in their product. Open Pose was developed by researchers at the Carnegie Mellon. It was released in the form of Python code or C++ implementation along with a Unity plugin. Users may input images, webcam feed, videos, IP camera, and more in order for Open Pose to work. It is compatible with Ubuntu 20, 18, 16, and 14 versions, Mac OS X, Windows 10 and 8, and NVIDIA TX2. Where we began. Our group began researching different pose estimation softwares to carry out our analysis. We researched three main pose estimation softwares, which is PoseNet, OpenPose, and AlphaPose. We eventually agreed to use OpenPose to extract the workout poses from a person using live video. We installed OpenPose, and in order to even get OpenPose to run, we had to run a demo file using Windows PowerShell. For example, we ran this on the Windows PowerShell so that we can run OpenPose on the webcam to display key points. And that's the example given. So this was the milestone one progress. Before we ran any code, I assigned one of our team members, Yosley Suarez, to record himself doing simple exercises as shown below. Okay. After constantly reviewing the instructions provided from the GitHub link that we proceed, we were finally able to use OpenPose to extract the pre-recorded exercise sampled into the following. Our team was also able to use OpenPose to produce an output of the original post estimation into a video showing the skeleton outline shown below. For the next task we needed to tackle was to find a way to produce an output of the actual coordinates from the pre-recorded workout videos. We found that saving the extraction videos again, this time as a JSON file instead of a.avi, I'm sorry, instead of a .avi video, produce the below file, which we believe may be the coordinates of each frame. Milestone 1 outcome. With milestone 1, we struggled the most with getting OpenPost to run correctly. All of our members downloaded the package from GitHub. However, we had issues with getting a live feed from the webcam to show the key points from the post estimation. After many failed attempts, we were able to adjust the code from the demo so that we could present that it is working with a live webcam. Milestone 1 outcome. Milestone 1 was successful with the fact that our group was able to run OpenPose in the Windows PowerShell for our sponsors to see. This milestone taught us how to take multiple steps to get to our destination. Some of the steps taken were to identify the problems that we were facing, establishing a theory as to why that problem occurred, trying to test those theories, putting a plan of action, and implementing measures of prevention. What we learned from milestone 1. We learned about pose estimation and its many uses in the IT industry. It takes a great deal of research and planning to complete a pose estimation correctly, and as a team, we could have been better prepared. Having joint key points move while a person is moving is an amazing advancement, and it was something that was very interesting to research. A few of the key things that our team took away from the milestone: one was getting familiar with OpenPose, learning how to troubleshoot in Windows PowerShell, and how pose estimation actually works.
My name is Claire West, and I will be presenting about Milestone 2. For our Milestone 2 assignment, it was a much more complicated assignment. In this milestone, our goal was to create code that would run OpenPose and produce two running windows side by side in a simple app. In one window, there was supposed to be the video of the workout with the pose extraction software running on top of it. And in the other window, the coordinates of the joints were supposed to be shown in real time, changing as the OpenPose skeleton went through the motions of the workout. The first step in Milestone 2 was, of course, creating the simple app. Our team struggled in this area as none of us were experienced in app development. The team members, myself and Cameron, were assigned to research Python and using PyCharm as our coding environment. The below screenshot is what our team was able to come up with for our app. We used PyCharm and were able to come up with a basic code following a tutorial for a GUI app, which was the closest solution we could find for our app needs. The screenshot below is the code that the previous slide produced, and unfortunately, this was the closest we were able to get to creating an app with the two separate windows. Milestone 2 caused more problems. After the allotted time passed to complete this part, we were unable to meet the goals. Our biggest setback was trying to get OpenPose and the internal webcam to open within the app. Because we were unable to get this part to work, we could not create the code that would produce the side-by-side windows required for this part of the milestone. Moving on to milestone 3, we ended up having to do an alternative assignment. The completion of milestone 3 originally depended on us successfully completing milestone 2. Since we were unable to get OpenPose to run in Python, we ultimately were not able to fulfill the goal for milestone 2. Because of the troubles we encountered during milestone 2, the group made the decision for the team lead to reach out to our sponsor and request an alternate assignment for the duration of the project. For our alternate assignment, we had to select 2 new pose estimation packages and compare them in terms of performance, speed, accuracy. The packages that our sponsor provided for us are listed below. Our assignment was to choose 2 of them and run them and compare them. We settled on Video Pose 3D and unsupervised geometry-aware representation learning. Unsupervised geometry-aware representation learning was created by Helge Roden, Matthew Salzman, and Pascal Fouet. This software proposes the use of images of the same person taken from multiple views. It does not require a 2D or 3D post annotation, and it uses a trained encoder-decoder to predict how an image would look from a specific viewpoint based on an image that was taken from a different view. It is a version of a 3D post estimation that limits the amount of annotation necessary to accurately pinpoint body parts in motion. It uses multi-angle viewings to determine pictures, and there are both supervised and unsupervised versions. Our other package was Video Pose 3D. Video Pose 3D is an efficient 3D human pose estimation in video using 2D key point trajectories. It was developed by Dario Pavlo, Michael Alui, and Christian Klaus.
I am Cameron Hankins, and my job in this presentation is to show some of the difficulties I went through and some of the things I was able to install when trying to get unsupervised geometry-aware representation learning to run on my laptop at home. And after we started to prepare to run the package, one of the first errors we came across was trying to download the X Windows system, which is a windowing system for bitmap displays that can be used. They can be manipulated with a mouse or with a command prompt, and it's useful for developing apps and stuff that use a GUI environment, a graphical interface, and that there aren't really any reliable links on the website pictured on the slide. I kept getting similar 404 errors like this one, and it made it really hard to try to get something that was both safe to download for my computer and reliable in the sense that it would work. And a lot of the mirror links that were available were just not links that I would want to be clicking on, so I didn't. And you can go to the next slide. Many of the issues that we came across when trying to run Video Pose 3D along with unsupervised geometry aware representation stuff is the use of a graphics card. And along with the graphics card, it really was not practical to try and purchase one for my computer. And I'm not even sure one would be reliable to use with my system I was going for anyway. And along with that, we had to download PyTorch. And after downgrading the Python and PyTorch 0.4, we were still receiving errors, and our code was failing to recognize the directory path. And as you can see on the screenshot there, that we just kept getting these same errors again and again, and it was really frustrating. But other things we were able to download that helped us, but we could not get the PyTorch or anything like that to download. We were still able to install the majority of the dependencies that were related to the graphics capabilities, but the NVIDIA or NVIDIA graphics card being a requirement was still a major stopping point. In the screenshot, I was able to download or use the PIP function on the command prompt to download other dependencies on the GitHub that were able to be downloaded onto my computer. And as you can see on the screenshot, when we were downloading a lot of these extensions and libraries that we use for Python, they would not fully install due to an environment error. And even when I would go in and tweak some of the code and tweak some of the folders that I would download these things in, I would still get environment errors based on either the incorrect file path or something along the lines with it not being compatible with the system. And CUDA or CUDA is a graphics related extension that can be installed in order to harness the power of GPUs, which would be a pretty big step into getting a workout assistant like we were researching to be able to work, because you need those graphical interfaces in order to get the proper annotation for your workout videos. And I was able to install a version of CUDA from the development website. And while I was able to get that installed and downloaded, it still kept giving us errors. And as you can see in the screenshot towards the bottom, when I would try to run demos that were included in the GitHub, it kept giving an error that one module or another. And in this screenshot, it says the torch module is not available, and we kept getting those errors, which made it really hard to work around, considering how crucial these extensions were to getting this representation package to run.
Hello, my name is Yosley Suarez, and now we're going to talk a little bit about the process we went through to run Video Pose 3D and some of the issues we came across. Now, in order to run Video Pose 3D, the first thing you need is the Human 3.6M dataset. And this is where we came across our first issue with the software. As this dataset is protected by a license, the only way to receive it was to register on the author's website and then have the website administrators manually accept registration and then allow you to download these files. And after registering, we waited about a week, and after receiving no response, we decided to email our sponsor and explain our concerns about proceeding with the software. The sponsor graciously offered us a copy of the dataset, and therefore we were able to proceed. But as of writing of this, it's been more than 2 weeks, almost 3, and I still haven't heard back from the admins of this website. So after installing the dataset provided for us by the sponsor and installing all the other dependencies listed on the GitHub page for Video Pose 3D, we proceeded to run the code provided in the GitHub. Unfortunately, as Cameron mentioned before, in order to run Video Pose 3D, it also requires an NVIDIA graphics card hardware. And due to the dependency of this code to use CUDA, and CUDA requires an NVIDIA graphics card, none of this was mentioned really in the GitHub page until we got further along into the installation process. And since so far we had been working on our personal laptops and other members were using Macs, I personally had to use my work computer in order to continue this project. But well, after sorting through this, using my work computer that had an NVIDIA graphics card, we continued with the project and soon ran into our first coding error where URL lib would not be defined. And when I went to the Python script and looked at this error in the request.py file in code line 105, we saw that urllib, it said it was not being, well, we see that it's not being explicitly imported. So we thought, well, maybe that's why it's giving out this error. So then the next thing I tried to do was explicitly import urllib and then run the program again by explicitly importing it. And then you see there in line 106, the edited code, but we still were receiving an error. Now we're seeing URL open is not defined, even though URL open is part of URL lib. And so I decided to go to a tutor, and after going through this with him, we agreed that our problem was mostly due to an out-of-date dependency or an incompatibility with our Python version, and maybe this was why URL lib wasn't working. So since I was currently at the time running Python 3.7, I decided to update to the latest Python version, which is 3.9. However, after upgrading to 3.9, now I'll get a different error where it said that the script was not recognizing a Kiwi solver dependency. And at this point, the tutor advised me to just go back to Python 3.7 and attempt to solve the URL lib issue, which seemed to be more plausible than trying to solve the Kiwi solver issue we were having. However, going back and circling around to the GitHub page for Video Post 3D, I realized that although the author mentioned Python 3 and higher was required, they also mentioned that PyTorch 0.4 and higher was required. And at that time, I was running PyTorch 1.8, which is higher than 0.4. So that I went to the PyTorch website and saw that PyTorch 0.4.0, it was only compatible with Python 3.6. So then what I did was uninstalled the other versions I had and went to Python 3.6. And that's when we made our first breakthrough and we were able to run the code required to run a test of Video Post 3D. So as you just saw in the previous slide, the program began to work flawlessly. The program would detect different poses such as walking, eating, sitting, walking a dog, and much more. However, this was just a pre-trained model test. I needed a way for this to work with custom pre-recorded videos, such as a workout video. And then this is where we kind of hit our final hurdle with Video Post 3D. In order to run Video Pose and the human 3.6M dataset on custom videos, and not just a test, there was then another program that was required in order to generate 2D key point predictions from videos without manually having to go and extract each individual frame. The program used by Video Post 3D authors was called Detectron 2 and previously known Detectron 1 in the previous version. For me, the problem wasn't installing Detectron. The problem was that Detectron only works with Linux operating systems. It's not yet made to work in Mac or Windows environments. Now, seeing as my computer at work was a Windows 10 machine where I had my NVIDIA graphics card, really the only solution I had was to try to run Ubuntu on a virtual machine. However, I quickly ran into the same problem that I had with my personal laptop. I needed an NVIDIA graphics card. And although my work computer had one, VMware Workstation categorizes all video cards as a generic SVGA 3D accelerator. It doesn't really mark it as an NVIDIA graphics card or an AMD graphics card. And at this point, I was out of luck. I would either need to invest in a paid version of VMware vSphere instead of Workstation in order for this virtual machine to recognize the hardware graphics card as an NVIDIA one and not a generic one, or dual boot my computer with Linux in order to proceed. However, since this was a company computer, I wasn't allowed to make such dual boot options and was therefore at a road's end with Video Post 3D. However, as you can see on the right, this is what Video Pose would have looked like had we had the possibility of running this and going through with the Linux version of Video Pose Detectron. And this video is the demo that is shown on the GitHub webpage.
My name is Tianna Porter, and I will be wrapping up the assignment. So basically, the outcome of our alternative assignment, after reaching out to our sponsor, installing the data sets he provided, utilizing the department's tutoring center, and doing research for countless hours, as a team, we ended up coming to the conclusion that we would not be able to properly run the packages with the resources we had at our disposal. Also, as a team, we believe that we fully utilized all possible resources that we had available to us. Unfortunately, since we were unable to complete this portion of the assignment, we believe that it was due to development issues and outdated data. Although our team was ultimately unable to achieve the goal for this specific capstone project, we did learn a great deal about pose estimation and its uses and generating code using Python and what not to do. We realized that your computer's hardware can have a large effect on being able to generate code, as we saw with the NVIDIA graphics card. We also learned that GitHub can be pretty difficult to navigate and that at times you may need to be prepared to reach out to the software developers just to request any additional requirements to be able to fully run a package. Another lesson we learned was that at times you may need to downgrade a software in order for it to work properly. There will be times where you will not always be able to use the most recent version. As a team, we also noted that it is important to note which GitHub packages are compatible with the system you're using, as some systems may be compatible, but many may not be. Our presentation will end with all the research and resources links that we used over the duration of this project.